In 7.3, we're doing trig substitution, and I'll call this is substitution with a twist. I made that up. Okay, in the first calc, in 1550, first calc, we had regular U substitution. Where we had something like this. U equaled some expression in X. I used X, but whatever the independent variable is. And then in this section, in 7.3, substitution, will look like this. The independent variable, I'll call it X. X equals some expression with theta. They're going to use the theta for the variable. In your book, there is a table of trig substitutions. And it looks like this. It's 3 columns. So you have some expression in the problem. And then we'll have our substitution step. And then the third column is a trig identity. I have found that the first 2 columns, they're the most important. If I know the trig identities, that third column will kind of come naturally to you on that. So for the first one, there's 3 substitutions we're working with. The first one is you have a squared minus x squared. And as I wrote this, I'm thinking this. A lot of times when you're reading your textbook and they have letters that are near the beginning of the alphabet, usually those letters represent a constant. So I've used A, but as a constant. You know, it might be something like 9 minus x squared in the problem, where then A would be 3. So if that's what's in the problem, here's your substitution. X equals A sine theta. And theta is defined from negative pi over 2, less than or equal to theta, less than or equal to pi over 2. The trig identity, 1 minus sine squared theta equals cosine squared theta. That you'll use that somewhere in the problem. The second expression is the square root of a squared plus x squared. Sometimes you'll see that as the square root of x squared plus a squared. I just used the commutative property. The substitution is x equals a tangent theta, where theta is defined from negative pi over 2 less than theta less than pi over 2. And the identity is 1 plus tangent squared theta equals secant squared theta. And the third substitution in this table would be if you have an expression like the square root of x squared minus a squared. The substitution is x equals a secant theta, and theta is defined from 0 less than or equal to theta less than pi over 2, or from pi less than or equal to theta less than 3 pi over 2. And the trig identity, secant squared theta minus 1 is tangent squared theta.